the amount of by increasing the amount of CO2 we push up into the atmosphere increases the greenhouse effect. And presumably what you mean by that is the greenhouse effect acts as a kind of insulation layer, therefore the heat radiating back off the Earth doesn't get away, stays with us, therefore we get hotter. Is that right?
Yes, that's right. Yeah.
Excellent, okay, fine. Why then, if we put more CO2 out there, and we increase that, what I would call an insulation area, I'm sure you thought it to be different, why is that then not suppressing the radiation coming from the sun, and therefore keeping us cooler?
Because there's radiation coming from the sun, it's shortwave radiation.
Oh, okay, and it goes straight through.
Thank you.
So it's exactly the same as a greenhouse?
Yeah.
Thank you. Yeah.
So there's this, that's a good question. So the wavelengths here, the wavelengths here are 0.25 microns to 2.5 microns. That's all down here. So it's long wave radiation. So the CO2 have got, if you look at the absorption bands of CO2, they're all in the 2 to 3 microns, 4 microns. Water vapor is all from 1 to 10. So there's the incoming radiation.
Can you go back to your slide where you've got the models on the bottom and then the amount of CO2 ejected on the top? Can you put some kind of scale on the upper one in terms of wait till we get there. No, the one where you've got the models on the bottom with the different outcomes, and then you've got the different feed-ins. Oh, hang on, it might have been that one, but bigger.
Do you mean the one with the sort of bell curves at the bottom and the graph at the top?
Yeah, that's
right at the end. That one there.
It's down to
no, sorry, it's not that one. It might have been the other one. Basically, what my question was you that's the one. In that upper one, can you give us some idea? I mean, you said that represents different possible human behaviours. But can you give us some idea of how those translate into real world? So, for example, where's the Tokyo agreement? Which one of those? And how likely you think they are?
So the red one is called business as usual. So that's that's burning all the conventional fossil fuels.
So if we did nothing, we
did actually not do nothing. The economies grow at the rate at which they're growing, and other countries industrialise. Then by 2200 we would have burnt all the available fossil fuel. That's conventional. So I think that's 6,000 petagrams of carbon. But there's actually, it could go higher. It could be 11,000 petagrams. So that's business as usual, and we've actually come off business as usual in the last couple of years. So there's been a flat, the rise in CO2 has not grown. Right? So for all of industrial time, the amount of CO2 that we're putting out has increased. The amount of CO2 that we're putting out has not increased.
And is that because of actual governmental changes?
Yeah, I think so. I think it's the switch towards. So in the UK, renewables now account for about 10 to 20% of our economy, of our energy. Same in Germany, France, China are moving that way. Actually, the biggest thing is that China aren't burning as much coal. That's why it's sort of leveled off a little bit. So we've now moved off this red one, and we're more tracking the yellow one. So the blue one here is closer. So in between these two is the Paris Agreement. So the Paris Agreement's hitting. It's going to hit around about. It's around about. Actually, it might be closer to this one. It's around about 3 degrees by 2100 if we keep the Paris commitments. So we're already seeing, that for successive IPCC reports from when they started until the most recent one, we were always on business as usual, and now we're not. So I think that's something to be quite pleased with. But yeah, this one is sort of unachievable. We're done. There's no way we can do that. I think there's even built into the Paris agreements is a usage of technology that doesn't exist. So this by 2050 would start having net removal of CO2 from the atmosphere, which we can't do at the moment. So yeah, I mean, I think they're all basically if we carry on where we are, we're moved off the red one. Which, you know, when I started doing this sort of thing, we were always on the red one.
Related to that, economic cycles, how much proportionally does that affect to business and economic?
So the 2008 crash did dent the rise in CO2, but it recovered far too far. Yeah, recovered by a year or two. So I mean,
it was noticeable.
It was noticeable. Yeah. And you know, in terms of growth of atmospheric CO2, the wars, the Second Olympics, those sorts of big changes, they are, it's not stopped.
Unusual activity.
Yeah.
Mostly they seem to be positive feedback.
Yeah.
We do have a habit of running away with ourselves. So something must be stabilising that to give you, I mean, obviously nothing's ever really.
Yeah.
What are the feedback loops that actually give you a negative feedback to give you a stabilising point?
So the main stabilising, climate stabiliser is silicate weathering. So what I mean by that is the turning of rock to soil. So that creates clay minerals. You turn a rock to soil, it creates a clay mineral. And that clay mineral won't contain all the ions that the rock had in it. And a lot of those ions then move to the ocean, where they stimulate productivity, get locked up in those shells basically. And those shells then get onto the deep sea, and then they go into the mantle. And then they actually then come out volcanoes. And actually the amount of the rate at which soil rocks turn to soil is temperature dependent. So the natural way in which climate regulates is if it gets warmer, you get more soils formed, more weathering, more deposition of ions in the ocean, more CO2 drawn out the atmosphere and put in the mantle. When CO2 is low and temperatures are cold, then the opposite happens. But those things happen on a climate change. The natural rate of climate change, CO2 change, is about 20 parts per million years, and we're doing 100 parts per million in 100 years. We're doing 1 or 2 parts per million per year, which is a million times faster than in nature. So the natural feedback, negative feedback, oh yeah, okay, yeah. Yeah. Well, yeah, I mean, that's the sort of technology that doesn't currently exist in a commercially viable sense. That would, that's exactly what we need to move from a sort of, we want to decouple economic growth from CO2, and so one way to do that is to put CO2 in the ground and carry on burning it, but you just capture it and put it into rock. And that was actually Jörg Matter from Ocean Earth Sciences in Southampton who led that study. And yeah, they put CO2 into basalt in Iceland, and within 2 years they'd removed 98% of what they put down. So I'm not sure it's economically viable yet.
The economically viable version of that is carbon capture and utilisation. So they're making sodium carbonate out of CO2 in India now. So they're used to making glass, which is stable enough to lock up to the CO2 for a while, for 1,000 years, let's say.
Yeah, and I mean there are a whole bunch of these different technologies that potentially could save the day. Yeah.
And right, there's 2 questions here. One is, when you compare or city, these elements died, what's the overall effect? Actually, one question so what are you most worried about?
which one is first? So yeah, ocean acidification is known as the second CO2 problem. It's actually it's better understood, but processes are better understood. The impacts on organisms are less well understood. But if you increase CO2, then it's an acidic gas that will dissolve in the oceans and makes the oceans acidic. The oceans have already acidified by about 0.1 gauge units. Doesn't sound like much, but it's a log scale, so that's a 30% increase in the concentration of hydrogen ions in the ocean. So it is affecting things like coral reefs and shells, shellfish in various parts of the coastal ecosystem. But they're more threatened by the temperature, especially corals. The temperature's rising, it's getting acidic, but actually it's the temperature, not the ocean acidification. In terms of what I'm most worried about, I think it's the ice sheets. I think the biggest threat. They're these sort of, they respond so sluggishly that the big continental ice sheets, Greenland and Antarctica, they've got about 65 metres of sea level locked up in them. So if you melt them, the sea level rises by 65 metres. So we'd be underwater. Well, you know, they can't react quickly. They don't react quickly. From what all we know from the geological record is that they won't respond. Well, they haven't responded in the past quicker than 2 metres per 100 years. But the problem is, it's like a freight train. Once you start them melting, even if we end up doing this, we end up finding some miracle technology that brings us back to some pre-industrial state. They're responding to the climate 100 years before we manage to do that, and they're still melting and melting and melting. And those are the sorts of long-term commitments that the choices we make now are going to make those things happen, whether we like it or not. So those are things. Yeah.
Obviously, if you're not burning coal or whatever to make energy, that's fine. But what about the fact that you are absorbing the sun's power, but you're turning it into electricity rather than just heating up the earth?
I think it's probably too small.
Yeah,
probably too small. It's like the energy that is released by burning the fossil fuel is 100,000 times less than the energy of a single CO2 molecule in the atmosphere. Basically, the heat will institute to burn fossil fuel CO2 is 100,000 times less than the energy that it captures in the atmosphere. So, yeah, I think a little bit of black as opposed to slightly reddish roof is a big
On your last slide, you said something like there's no doubt that the temperature is going up.
Yes.
Humans are causing it.
Yes.
Well, some people do doubt that.
Yes.
Presumably, some of those people are called scientists.
Yeah.
And presumably, that some of those people are sincere in what they believe and their doubts. So, how would you summarise the position of someone like that?
I don't know. Well, people used to believe the Earth was flat, and they were quite sincere about it. I think there's quite a lot of parallels with before I was interested in climate science. I did my PhD on geochronology, which is working out how old rocks are, and there was a similar viewpoint that the Earth's only 6,000 years old, and we all know why that might be. But geochronology says that it's actually 4.567 billion years old, and so it's a similar kind of. I guess it's that they might well believe that the climate hasn't warmed, but I would question whether it's legitimate. Their legitimate view is science-based.
Can I ask a scientific question in the same vein?
Yeah.
This leads on from your question. So, as a scientist, I'd like to know whether or not what went on 50 million years ago is at all a good proxy for what happened in the last 100 years. So, is it a good proxy for burning coal in China, whatever it was that happened 50 million years ago? And are you addressing that question?
So no, I'm not. If I was using the climate of the past to say this is what the climate in 100 years is going to be. So yeah, if we look back and we said it was 50 million years ago, it was 12 degrees in China, then that's what it's going to be like in 2 years' time. Then that would be wrong.
But in a sense, that's what you did.
No,
you said the CO2 levels 50 million years ago which were caused by natural processes are the same as CO2 levels, or whenever it was, caused by burning coal. What about all the steps in between?
Well, that's why we're looking
at... Are the
at...
two the same?
So that's why we're looking at the term equilibrium climate sensitivity. So that is the models run until they are in equilibrium, which is much closer state to the geological past than the transient that we're in now. So when you look at the amount of warming that happens in a climate model on a 100-year timescale, it's about a third of the warming that happens at equilibrium. Sorry, 2/3. So what we're seeing now, the warming we're seeing now in response to the forcing is probably about 2/3 of the full response. So what we're looking at the geological past is the full response, and what we're comparing in the models is the full response in the models to the full response in the past, and then we're comparing how the models then look at the transient, shorter response. So it's not quite the same, but we're saying we're evaluating how well the models stimulate the equilibrium climate state, which is best represented by the geological past, because there is no transient that is an analog. Yeah.
Personal question, really, before. If Donald Trump and Ted Cruz are skeptics of climate change, do you know of any political statements that, in their uncertainty, have put some funding into doing some more research so they have clarity?
What do you mean by that?
Well, I mean, anybody who doesn't really is not sure where the truth is. If you're in a hypothetical position like Trump, you would then say, well, put some money in there and get some results.
Yeah, so it's just sorted out sort of thing.
So do you think like it's going to happen?
I mean, the messages that they're coming out with is the opposite, really. That they're sure that nothing's happening. So I've heard that they want to close the climate science at NASA. £3 billion that's normally spent on studying the Earth's climate through NASA and exploring other planets as well. So they're closing stuff down.
Is there a falsification?
Sorry, can you speak up a bit? Can't hear at the back.
Oh, is there a falsification that go through to test opposing you? Not that you like it, but is there someone has some money to put in there?
I mean, they've tried. I mean, in America in particular, they've had so-called skeptic groups revisit the Berkeley Earth. They're called. It was a skeptic. I think he was a physicist from Berkeley in California. He had a lot of funding, private funding, to show that the temperature records were all cooked, that they were bogus. These 150 years worth of temperature records, and they came up with a record that was identical.
I mean, the issue is that in the post-truth age, it doesn't matter if you falsify Donald Trump's view; people will still vote for it.
And actually, in 2009, he was all in favour of the Copenhagen climate goals. So he's changed his view since then, for whatever reason.
Kind of in this area, one of the skeptic things seems to be that the climate scientists keep changing their minds. Now, the most extreme form of that is if you go back to popular science programmes of, say, 40, 50 years ago, they were talking about when's the next ice age due.
Yeah.
A comparison, well, way slower than what we're doing, but comparatively short-term effect compared to the big change back to the USA. What's caused the change in the climate science perspective from saying the next thing up is ice age to the next thing up is well, we're in warming?
It's an interesting point. So I mean, I remember, well, the reason like I said, I used to be a geochronologist, and the reason I got into climate science, I remember sitting with a colleague of mine when I was doing my PhD, and I was saying that the Earth chucks out lots of CO2 from volcanoes. This is all natural cycles, and that was in about 1990, which is in here, right? And you see, there's lots of this noise in the climate system. And my colleague at the time said, well, no, now we can be pretty sure that actually we're outside of the envelope of natural variability. Whereas when you're in 1950s, it's the same mistake that all these climate skeptics are saying there's a pause in global warming. You have to look at the bigger picture. There's so much. Only 2% of the heat capacity of the climate system is in the atmosphere. 98% is in the oceans. So all of this up and down and these long-term trends is just differences in the amount of heat the oceans are storing. We can't measure the oceans very well because it's really difficult to measure them, and we don't have records that extend this far. So when you're looking at thermometer records on the Earth's surface, that's only 2% of the climate system, the heat in the climate system. So of course it's going to show ups and downs. So you have to look at a scale that's broader than those changes in ocean atmosphere heat storage. So yeah, that by about Jim Hansen in 1988 famously stood in front of Congress and said, we're now pretty sure, or 95% sure, that we're outside of the envelope. So there's purely the observational record to base that on, but then there's the whole science. Climate science says there should be a relationship, and it's associated. It's like making you make a hypothesis and you test it, and that's what we're doing. And certainly, by the time the guys were predicting the global cooling, probably gave up by then. Yeah, and rightly so. And if this comes down, all the climate scientists were going to go, okay, we were wrong. Why were we wrong? But you've got to act on the evidence as it is, and I think that we've built a pretty good case.
So is the global monitoring of ocean temperatures then now? Is there a programme?
Yeah, there is. It's called the Argo programme. It's very expensive. So they have these floats that go up and down the ocean. I think there's 13,000 of them. Pretty much every square something kilometre. I've seen them, and it's every grid square, but it depends how big your grid squares are. But it's like it's 13,000 of them, but they only go down to 2,000 metres, which is the majority of the ocean. But the mean depth of the ocean is about 3,400 metres, so we're missing some. But actually, it's quite well mixed on that lower part. So now we have a good idea. But pre 1990s. Then depended on what measurements ships had taken, and so. But now we have a pretty good.
And who manages that? Is that
So it's a multinational $1 million effort with. So the scientists at the National Oceanography Centre play a very strong part in that. The UK have a certain number, but by far it's the US. So this is why it's it could be catastrophic if Trump pulls the funding in these big infrastructure programs that the US just always lead on.
So going back to one of your slides, you've got 75% carbon dioxide, you've got 75% water vapour, and you've got the other gases in which carbon dioxide is part. A lot of gas is now being created, manufactured, utilised, so for instance for air conditioning systems that are up to 1,000 times more than CO2, and the kind of the increase in welfare of prosperity of people getting these air conditioning systems and things. Are we seeing that is making an effect on these other gases? They're obviously never going to reach the same as CO2, but because the effect that they have is so much greater, that smaller percentage is having a bigger impact and increasing return.
So yeah, you're talking about the sort of like CFCs and various other man-made greenhouse gases. Yeah. I don't know. I would obviously the main issue with CFCs is that they react to ozone and they destroy the ozone hole, and that is healing so slowly. So yeah, I don't know whether that's.
I know for a fact that Barley Works they are developing gases for air conditioning systems that are maybe 100 times worse than CO2 instead of 1,000. Problems that's very explosive.
I guess that's
holding advantage on that.
I guess the advantage is that it's small fry compared to the carbon dioxide in the atmosphere. I mean, there's trying to think of numbers. There's 1,000 petagrams. That's 1,000 times 10 to the 50 grams of carbon in the atmosphere. So I think the other gases would be more. Those sorts of gases. Yeah.
They were talking a while about as the temperature increases, permafrost and ocean, frozen ocean sediments will defrost and release more methane and others. Is that going to play more of a positive feedback?
I was just chatting to this gentleman earlier about it. So, well, currently it's quite a well-known positive feedback that is receiving a lot of attention. So one thing would be those geological comparisons between, they're not in that process, melting of permafrost, increasing the methane content of the atmosphere. So methane's a 26 times more potent greenhouse gas than CO2. Those aren't built into climate models. So if there was a big disconnect between the climate models and the geological record, then firstly you might think that might be a process that happens, but there's not. Also, observations like there was very little methane released from the Deepwater Horizon spill, remember in the Gulf of Mexico? Most of that methane was digested in the water column by microbes. And there are venting methane off the shelf of Norway, and those bubbles, you can see there's shallow water, 80 to 100 metres, and you can see the bubble plumes, but when you fly a drone over the top, there's no extra methane in the atmosphere. So they're just not escaping from the water. So we actually think the methane hydrates or this methane permafrosting might not be that big a player. It might have a small role. Yeah, I mean, so there's been one study that looked at the methane. It's quite a long-term study that's looked at methane in some town in Canada, and then one time of the year in the summer, it's the wind blows in one direction, and they've been having this methane record. And over the last, 10, 15 years, despite temperatures rising, there's been no change in the summer methane content. So it's probably turning to carbon and not getting out, because it's quite reactive, so the methane might well just be digested and it's not going to be released to the atmosphere. Insignificant positive.
Are you using boron isotope analysis for age determination or something?
So that's what gives us the ocean pH in the past. The boron isotope composition tells us the pH at which those shells lived at. And then from that we can work out the atmospheric.
Just from the specification?
Well, no, because much as CO2, the anthropogenic CO2 is dissolving in the surface water, making the oceans acidic. The ocean's pH basically tells us the CO2 content in the atmosphere. So the more CO2 in the atmosphere, the more acidic the oceans are. So if we know the pH of the oceans,
so do you date them though?
So yeah, right. So we date them. A whole bunch of there's a whole on dating these cores. So very simply, we know roughly how much they keep in time. That's one thing. There will be there's regular reversals of the magnetic field of the Earth. Last one was about 800,000 years ago, south going north, and that imparts magnetism on the sediments that you can measure. So that gives you at least 1 point. So we'll know sort of 5 meters down in the core, the magnetism of the sediments is flipped the other way. So that is there are then some cores that might have ash layers in them. Volcanic ash, we can date those volcanic ash layers. And then from having a big sort of archive of cores, some of which are very well dated through these different methods, you can actually use the climate cycles to what's called tune your records. So if you've got a climate cycle in one core, then you compare it to a well-dated core and work out what the age was that way. And also biostratigraphy, so disappearance and appearance of certain things.
I was thinking the sort of archaeological carbon isotope analysis where quite obvious when you get a clock setting when the material dies, so that there's no more transformation, and that sets the clock at 0.
To the half-life is, no, we do for the top 20,000 years, but the half-life is 7,500 years.
So you're not using boron for that?
No, we're not using boron for that. It's not radioactive, it's stable.
No more questions?
Yeah, one last one.
Okay.
What is it we should be telling Donald Trump to do? And our politicians.
You don't use words.
Yeah,
well, yeah, well, yeah.
Yeah.
Shooting would be a good idea, but yes.
Well, I think a sensible thing to do would be to invest in green energy. That would be I mean, look at the price of solar panels, how much they've dropped. Investment. The oil industry has got a lot of subsidies and a lot of infrastructure that any other nascent energy has to compete with. Inherently, oil is delivered by road. We have the infrastructure and we get petrol pumps. Well, the whole society is geared up around oil. So it's heavily subsidised in many different ways, not just directly in exploration teams. It's built into our very fabric, really. And we need to help other technologies because they're not so well subsidised. I think I followed our the Romsey MP in Parliament as part of the Royal Society pairing scheme, and I happened to be in Parliament when the Conservative or coalition government decided to cut the subsidies for solar panels from 95 to 2 or 3% or something. And it was just devastating for the industry because why would and devastating for green energy in general, because why would you come to a country that does that, builds you up and then just cuts you down? So I think that my message would be to be investing in green energy, because you could be really rich. That's what Chinese do.
You said why do politicians cut those things down?
Yes.
Because politicians don't think about that. It's always.
Yeah.
They have such
political cycle
of spending the money elsewhere. I think even if we change it in the West, you mentioned Germany and other areas like Germany, so you still have the other countries who are trying to catch up in terms of how they live. And they should definitely be oriented towards what the West did in the past.
Exactly.
American movies and whatever, everyone drives a car. So people in...
Well, so a big chunk of the Paris Agreement was how much money should the developing world pay the developed world pay the developing world to avoid the same mistakes that we did. And that's the stuff that Trump's going to try and get out of. It's the billions of dollars that Obama said he'd pay the Chinese and Indians to have a green economy. Okay.